I'll be solving this problem in the video here, and it's about the conversion between Celsius and Fahrenheit and coming up with that formula. So the problem gives us two pairs of temperature values where it's the same temperature measured in both Celsius and Fahrenheit. So look at those pairs like you would an ordered pair, and I'm listing the Celsius first. That's going to be in a sense my X. I'm listing the Fahrenheit second, which would be like my Y. And so if you have 2 points, you can find the slope between those points. And then our formula is to subtract the y values on top and then subtract the x values on bottom. And make sure you're using the same point first on both times. So since I'm doing 221 minus 77 on top, I have to start with this x value on bottom, 105 minus 25. And that reduces down to 9/5. And so we found the slope of a line that's connecting those 2 points. It's 9/5. And then here's typically the equation that we can use, slope-intercept form, y equals mx plus b. M is our slope. In this example, our y is our Fahrenheit and our x is our Celsius. So our Fahrenheit equals 9/5, that's our slope, Celsius plus b. So all we need to do to get this line, this equation of this line for our conversion is to find b. That's the only unknown value we need. And so to get that, we can use either one of our points, it doesn't matter, and plug in the values for Fahrenheit and Celsius. So I'm just going to use this first one because the numbers are a little bit smaller. And that is a 7 there. So 77 goes in for the F and 25 goes in for the C. And you plug those in. And then 9/5 times 25 gives you 45. And minus 45 from both sides, you'll get that B is equal to 32. And so that gives us all we need to write our complete equation for the conversion. It's Fahrenheit equals 9/5, our slope, times Celsius plus what we solved for B, which was 32. Now, if we wanted to flip this around and solve for C, the easiest way is just to work with this equation we already got and just get C by itself. And so I'm going to need to subtract 32 from both sides. So I'm going to have F minus 32 equals 9/5 C. And the only thing left is to undo this multiplication, 9/5 times C. To undo something multiplied, you divide by it. So essentially we want to divide by 9/5, which when you do fraction division, that's the same thing as multiplying by the reciprocal. So we're going to multiply on both sides by 5/9. And that's going to leave us with just a C over here. And we have to multiply this entire side by 5/9. So we want to indicate that with parentheses. We're going to take the entire side and multiply it by 5/9. And that leaves us with our equation solved for C. And for the last part of this problem, we're trying to figure out what temperature value Fahrenheit will equal Celsius. Both scales will show the same reading. So I'm going to use this equation. And if I'm working with the assumption I want where F is the same as C, I can just change, instead of writing F, I want to write C here because Fahrenheit is going to be equal to C for this temperature value. So as you'll see down here, I have this same exact equation, but I've just, since F is going to be equal to C for this temperature value, I'm writing a C where I used to have an F. So now I'm going to solve that and see what that value is for C that makes this equation true. And so I went ahead and wrote that 1C is the same as 5/5 C because I'm going to need to subtract 9/5 C from both sides. And so when you subtract 9/5 C from this side, it cancels out. And over here, you do 5 minus 9, you would get negative 4/5 C. And on the right side, you're just left with a 32. So do that fraction, subtraction. And then you need to divide both sides by this number here. Divide by negative 4/5. And when you do 32 divided by negative 4/5, you get the answer negative 40. And so if the temperature outside is negative 40, the Celsius scale says negative 40, the Fahrenheit scale says negative 40 as well.